Hi everyone, welcome back to another video with Talent Catalyst AI, where we strive to give you industry specific artificial intelligence knowledge which will help you grow in your career path. Today's topic of discussion for this video is totally about normal distribution, which is one of the most prevalent probability distributions across statistics. We'll try to understand the meaning of normal distribution using a simple use case, wherein you have imagine that you have a class of students who had recently taken a test which had scores ranging from 0 to 100, right? Now you want to distribute the students across the class based on the scores that they had gotten in the marks. Let's have a 2D graph to do that. On the x axis we have the scores of the students, test scores basically, starting from 0, 10, 20, 30, 40 and so on till 100. We're keeping bins of a 10. On the y-axis we have the number of students who essentially have gotten these marks. If you want to interpret this particular graph, let's say 15 marks. Let's say there is a point over here and this particular number is 20. So this essentially means 15 marks were scored by 20 students. What we'll do is we'll mark the distribution of all the students in this similar way. How many students have got marks in each of these categories? It's kind of a scatter plot that we are plotting. Now let's understand the example that we just saw, or the use case of the number of students and their distributions with respect to the scores that they have got in the test, and analyze the characteristics, the 4 important characteristics of the normal distribution, namely bell-shaped curve, mean, median, mode, standard deviation, and the probability density. The first one, as the name itself suggests, that the normal distribution is essentially a bell-shaped curve. That is, it is bulged in the middle and it gets tapered at the edges, both positive and the negative edges. The peak of the curve lies on the average score. That is this point. The peak of the curve lies over here, saying that most of the observations, or in our case, most of the students have a average score, that is the mean score. So let's try to visualize it again. Let's draw the axis over here. We have the score of the students, the test scores on the x-axis, and on the y-axis we have the number of students. The bell-shaped curve says that since it's bulged at the center, most of the students have a test score of essentially which is near to the mean. The second characteristic is mostly about the mean, median, and mode. It says that the 3 M's, the mean, median, and the mode in the normal distribution are co-located or are equal. So all the three over here, all the three for this normal distribution reside at the middle point, that is over here. It also means that half of the students have scored above this mean value score, or half of the observations are above this and half of the observations are below this, or half the students have scored less than the mean score of the students. Now let's discuss the third and one of the most important characteristics of the normal distribution, that is the standard deviation. So standard deviation is a measure of how dispersed the data is in relation to the mean. So if the standard deviation is low, we'll check it over here. If the standard deviation is low, that means the data is highly cluttered around the mean. Most of the data that you see is cluttered around the mean. The density of data is higher around the mean. If the standard deviation is high, meaning most of the observations are not cluttered around the mean, right? They are not tightly bound. So you see the difference here. The data is congested around the mean. Here the data is distributed along the mean. It's not there exactly at the center. So the characteristics of normal distribution with respect to standard deviation says that in a normal distribution, about 68% of the score falls within one standard deviation of the mean, 95% falls within two standard deviations of the mean, and 99.7 falls within 3 standard deviations of the mean. What this means is, let's say we have a mean of 60 marks and a standard deviation of let's say the mean is 60 and the standard deviation we have is 10 marks. So we have a mean of 60. If we subtract 10, we have 50 marks. If we subtract 40, then we get 30. On the positive or the brighter side, we have 70, 80 and 90, meaning the average score of the class students is 60 in this test. 68% of the students lie between the score of 50 to 70, meaning 68% of the total class, if there were 100 students in the class, 68 of them have scored between 50 to 70 marks. Going further, 95% of the students have scored marks between 40 and 80, and it goes on for the 3 standard deviation as well, saying that 99.7% of the students have scored marks between 30 and 90, that is 3 standard deviations plus and minus. Coming to the fourth characteristic of a normal distribution, that is the probability density, that we have already seen that the height of the curve at any given point represents the probability of the student receiving that score. Scores near the mean in a normal distribution specifically have a higher probability of occurring. That means students having scored marks of 60 or 50 to 70 have a higher probability of occurring as compared to students with scores of 30 or 40. This is evident from the graph because it's bulging in the middle. Now let's try to understand the significance of a normal distribution. Why exactly do we need a normal distribution? The first and most important thing is its commonality in nature. Normal distribution is something which is very commonly seen in our daily lives. Most of the phenomena that occur around us, or the observations, if they have to be distributed across a distribution, probability distribution, most of them follow a normal distribution, saying that if an observation were to occur around the mean, it has the most probability as compared to otherwise. For instance, if we look at height of the people, most of the people are heighted at an average as compared to the edges. For instance, if the average height of any person in India is 5.5 feet, most of the people would be heighted at this location and not at 7 feet or 3 feet, which are the positive and negative ends. The second important significance of the normal distribution is the normal distribution plays a very significant role in the central limit theorem, which states that the sum or average of the large number of independent and identical distributed random variables approaches a normal distribution regardless of the original distribution. The third factor of significance for a normal distribution is its power of statistical inference. In many statistical methods, such as hypothesis testing and confidence intervals, we make a lot of assumptions regarding the distribution of the data. Since normal distribution is easy to comprehend, and due to its mathematical traceability and simplicity in calculation, we use normal distributions for making a lot of assumptions for distribution of the data, the probability distribution in data. Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.